Welcome to the calm cosmos. In the vast silent expanse of the cosmos, where stars ignite and galaxies swirl, our perception of reality often feels absolute and undeniable. We trust our senses, our memories, and our logical deductions to paint a faithful picture of the world around us. Yet, what if this seemingly solid reality is, in part, an intricate construction, an illusion woven by our brains, our senses, and the very fabric of the universe itself? This profound question, explored by philosophers, scientists, and mystics throughout history, invites us to embark on a journey into the nature of perception, consciousness, and the fundamental constituents of existence. The calm cosmos, in its boundless mysteries, whispers of realities far more complex and subjective than we often assume. Our exploration begins with the most immediate architects of our reality, our senses. We often believe that our eyes, ears, nose, tongue, and skin provide us with a direct, unfiltered window to the world. However, scientific understanding reveals that our senses are not passive receivers of information, but active interpreters, filtering, organizing, and even constructing the data they receive. What we perceive is not the raw reality, but a highly processed and personalized version of it. The calm cosmos, in its intricate design, has equipped us with sensory systems that are both remarkable and inherently limited. Consider sight, arguably our most dominant sense. We see a vibrant world of colors, shapes, and movements. Yet, our eyes only detect a tiny fraction of the electromagnetic spectrum, the visible light. Beyond this narrow band lie radio waves, microwaves, infrared, ultraviolet, X-rays, and gamma rays, all invisible to the human eye. A snake perceives infrared, a bee sees ultraviolet, and a bat navigates by echolocation, using sound waves beyond our hearing. This means that a vast amount of information about the universe is constantly passing through and around us, completely undetected by our primary sensory organs. The calm cosmos, in its full spectrum, remains largely unseen by human eyes. Furthermore, our brains actively construct what we see. The retina, at the back of our eye, contains a blind spot where the optic nerve connects, yet we never perceive a hole in our vision. Our brain fills in the missing information, creating a seamless, albeit fabricated, visual field. Optical illusions further demonstrate how our brains can be tricked, interpreting visual cues in ways that don't align with objective reality. The famous Müller-Lyer illusion, where two lines of the same length appear different due to the direction of their arrowheads, is a classic example. Our perception is not a direct reflection of reality, but an interpretation. The calm cosmos, in its visual paradoxes, reveals the constructive nature of our perception. Similarly, our sense of hearing is limited to a specific range of sound frequencies. Dogs hear ultrasonic whistles, and elephants communicate using infrasound, both beyond human auditory perception. Our ears also filter out a tremendous amount of background noise, allowing us to focus on relevant sounds. Imagine trying to have a conversation in a crowded room if your ears processed every single sound with equal intensity. Our auditory system actively selects and enhances certain frequencies, allowing us to make sense of the acoustic world. The calm cosmos, in its symphony of vibrations, is selectively heard by human ears. Our other senses operate under similar constraints. Our sense of smell detects only a fraction of the chemical compounds in the air, and our taste buds are limited to a few basic tastes, with the rich tapestry of flavour largely constructed by our olfactory system. Our sense of touch, while seemingly direct, is also an interpretation of pressure, temperature, and texture, influenced by the density of receptors in different parts of our skin. Each sense provides a partial and processed view of reality, and it is the brain that stitches these fragmented pieces together into a coherent, albeit subjective, whole. The calm cosmos, in its sensory fragments, is unified by the brain into a personal reality. Beyond the limitations of our individual senses, the very act of perception is influenced by our expectations, memories, emotions, and beliefs. We don't just see with our eyes, we see with our minds. If we expect to see something, we are more likely to perceive it, even if it's not entirely there. This phenomenon, known as perceptual set, demonstrates how our internal states can shape our external reality. For example, a hungry person might be more likely to perceive food-related images in ambiguous stimuli. The calm cosmos, in its subjective interpretations, is coloured by our internal states. Our memories also play a crucial role in constructing our reality. When we recall an event, we don't retrieve a perfect, unblemished recording. Instead, our memories are reconstructive, influenced by our current mood, new information, and even suggestions from others. This means that our past, which feels so real and immutable, is also a dynamic and often illusory construction. The calm cosmos, in its temporal flow, is shaped by the fluid nature of our recollections. The phenomenon of confabulation, where individuals unknowingly create false memories to fill in gaps in their recollection, further highlights the brain's propensity to construct coherent narratives, even if they are not entirely accurate. This is not a deliberate attempt to deceive, but an unconscious effort to maintain a consistent sense of self and reality. The calm cosmos, in its narrative constructions, reveals the brain's tireless effort to create meaning. Our emotions also profoundly influence our perception of reality. When we are happy, the world can appear brighter and more inviting. When we are sad or anxious, the same world can seem bleak and threatening. This emotional colouring of reality is not merely a metaphor. It is a neurological phenomenon where our emotional state literally alters how our brains process sensory information. The calm cosmos, in its emotional reflections, mirrors our inner landscape. Consider the placebo effect, a powerful demonstration of how belief and expectation can influence physiological and perceptual reality. When a person believes they are receiving a treatment, even if it's a sugar pill, their symptoms can improve. This is not just a psychological phenomenon. Studies have shown that placebos can activate the same brain regions and release the same neurochemicals as active drugs. This suggests that our beliefs can literally alter our brain chemistry and physiological responses, blurring the lines between subjective experience and objective reality. The calm cosmos, in its intricate connection between mind and body, reveals the profound influence of belief on our physical reality. Beyond our individual perceptions, the very nature of reality at its most fundamental level, as revealed by quantum physics, suggests an inherent probabilistic and observer-dependent universe. Quantum mechanics, the most successful scientific theory ever developed, describes the behavior of matter and energy at the atomic and subatomic scales. And at these scales, reality behaves in ways that defy our classical intuition, hinting at a deeper, more elusive truth. The calm cosmos, in its quantum depths, whispers of realities far more complex and subjective than we often assume. One of the most perplexing aspects of quantum mechanics is the concept of superposition. A quantum particle, such as an electron, can exist in multiple states simultaneously until it is observed or measured. For example, an electron can be in two places at once, or spinning both clockwise and counterclockwise, until an observation forces it to choose a single state. This means that before observation, the reality of the particle is not fixed but exists as a probability distribution of all possible states. The act of observation, in a sense, collapses this wave function, forcing the particle into a definite state. The calm cosmos, in its quantum indeterminacy, suggests a universe with an element of genuine chance. The famous double-slit experiment vividly illustrates this phenomenon. When particles like electrons are fired at a barrier with two slits, they behave like waves, creating an interference pattern on a screen behind the slits, as if each particle passed through both slits simultaneously. However, if we try to observe which slit the particle goes through, the interference pattern disappears and the particles behave like discrete particles, passing through only one slit. The act of observation changes the reality of the particle, suggesting that reality is not fixed until it is measured. The calm cosmos, in its quantum weirdness, challenges the very notion of an objective reality independent of observation. Another mind-bending concept is quantum entanglement, often described as spooky action at a distance by Albert Einstein. When two quantum particles become entangled, their fates are intertwined, regardless of the distance separating them. If you measure a property of one entangled particle, the other entangled particle instantaneously assumes a correlated state, even if they are light years apart. This instantaneous correlation seems to defy the cosmic speed limit of light, suggesting a deeper, non-local interconnectedness in the universe. While entanglement cannot be used for faster-than-light communication, its existence implies a profound unity in the fabric of reality, where seemingly separate entities are intimately linked. The calm cosmos, in its entangled particles, reveals a profound unity that transcends spatial separation. These quantum phenomena suggest that reality at its most fundamental level is not a solid, objective entity waiting to be discovered, but rather a fluid, probabilistic, and observer-dependent construct. The universe, in a sense, is not fully real until we interact with it. This has led some physicists and philosophers to propose that reality is an emergent property, arising from the interactions between consciousness and the quantum field. The calm cosmos, in its quantum depths, whispers of realities far more complex and subjective than we often assume. Beyond the scientific and philosophical perspectives, cultural and social constructs also play a significant role in shaping our perception of reality. The language we speak, the stories we tell, the values we hold, and the social norms we adhere to all influence how we interpret the world around us. What is considered real, true, or normal in one culture might be completely different in another. The calm cosmos, in its diverse human experiences, highlights the varying degrees of our shared reality. Language, for example, is not just a tool for describing reality, it actively shapes it. The Sapir-Whorf hypothesis suggests that the structure of a language influences the speaker's worldview or cognition. For instance, cultures with many words for snow might perceive and categorize snow in more nuanced ways than cultures with only one word. This means that our linguistic framework can influence how we perceive and categorize the world, creating different realities for different language speakers. The calm cosmos, in its linguistic diversity, is interpreted through countless conceptual frameworks. Our social groups and communities also play a powerful role in constructing our shared reality. We tend to gravitate towards individuals who share our beliefs and values, reinforcing our existing perceptions and creating echo chambers where alternative viewpoints are rarely encountered. This can lead to a phenomenon known as confirmation bias, where we selectively seek out and interpret information that confirms our existing beliefs, further solidifying our perceived reality. The calm cosmos, in its social constructs, reveals the powerful influence of collective belief on individual perception. Consider the concept of money. It is a social construct, a shared belief system that assigns value to pieces of paper or digital entries. In reality, a dollar bill is just a piece of paper, but our collective agreement to assign it value makes it a powerful force in our lives. This highlights how shared beliefs, even if they are arbitrary, can create a powerful and tangible reality that influences our behavior and shapes our societies. The calm cosmos, in its economic systems, is built upon shared illusions of value. Even our understanding of time and space, which feel like objective realities, are influenced by cultural constructs. Some cultures perceive time as linear, moving from past to present to future, while others perceive it as cyclical, with events repeating in patterns. Similarly, our perception of space can be influenced by our cultural background, with some cultures emphasizing absolute directions, north, south, east, west, and others relative directions, left, right, front, back. These cultural variations demonstrate that even the most fundamental aspects of our reality are not universally perceived. The calm cosmos, in its cultural interpretations, is experienced through diverse temporal and spatial frameworks. In conclusion, the idea that reality is, in part, an illusion, is not a nihilistic proposition, but an invitation to a deeper understanding of ourselves and the universe. It suggests that what we perceive as solid and objective is often a complex interplay of sensory input, cognitive processing, emotional states, cultural constructs, and the inherent probabilistic nature of the quantum world. The calm cosmos, in its boundless intricacies, continues to reveal its wonders, inviting us to perceive, to understand, and to marvel at the extraordinary nature of existence itself. This journey into the illusion of reality is not meant to undermine our experience of the world, but to enrich it. By recognizing the constructed nature of our perception, we can become more aware of our biases, more open to alternative perspectives, and more appreciative of the incredible complexity of the human mind. It encourages us to question, to explore, and to embrace the inherent mystery of existence. The calm cosmos, in its profound depths, holds the ultimate secrets of existence, waiting to be unveiled by the curious minds of humanity. It's a testament to the power of human inquiry, a reminder that the more we learn about the universe, the more we realize how much more there is to discover, and how deeply interconnected we are with the fundamental fabric of reality. Let's delve deeper into the fascinating world of our sense of touch, or tactile perception. While we often think of touch as a single sense, it is a complex mosaic of different sensations, including pressure, vibration, texture, and temperature. This rich tapestry of tactile information allows us to explore our environment, interact with objects, and communicate with others in profound ways. The calm cosmos, in its tangible reality, is constantly being interpreted through our sense of touch. Our skin, the largest organ in our body, is the primary organ of touch. It is populated with a vast array of specialized mechanoreceptors, each tuned to a specific type of tactile stimulus. As we've discussed, Meissner's corpuscles detect light touch and vibrations. Pacinian corpuscles respond to deep pressure and high-frequency vibrations. Merkel cells are responsible for sustained pressure and fine tactile discrimination, and Ruffini endings respond to skin stretch and sustained pressure. This diverse population of receptors allows us to perceive a wide range of tactile sensations, from the gentle caress of a breeze to the firm grip of a handshake. The calm cosmos, in its physical interactions, is meticulously mapped by these diverse pressure sensors. The information from these mechanoreceptors is transmitted to the brain via two main pathways. The dorsal column medial lemniscus pathway, which carries information about fine touch and proprioception, and the spinothalamic pathway, which carries information about pain and temperature. These pathways ultimately project to the somatosensory cortex, a region of the brain that creates a detailed map of our body, with different areas corresponding to different parts of the skin. The size of the representation of each body part in the somatosensory cortex is proportional to its sensitivity, which is why our hands and lips, with their high density of mechanoreceptors, have a much larger representation than our back or legs. The calm cosmos, in its intricate design, has optimized our sensory organs for specific tasks. Our sense of touch is not just about passive reception, it is an active and exploratory sense. When we want to learn about an object, we don't just passively touch it. We actively explore it with our hands, running our fingers over its surface to feel its texture, shape, and temperature. This active exploration, known as haptic perception, allows us to build a rich and detailed mental representation of the object. The calm cosmos, in its tangible reality, is actively explored and understood through our sense of touch. Touch also plays a crucial role in our social and emotional lives. A gentle touch can convey comfort, affection, and support, while a harsh touch can signal aggression or anger. The act of hugging, for example, releases oxytocin, a hormone that promotes bonding and social connection. This highlights the profound influence of touch on our emotional well-being and our ability to form relationships with others. The calm cosmos, in its intricate connection between mind and body, reveals the profound influence of touch on our emotional landscape. Let's now explore the fascinating world of our sense of taste, or gustation. While often taken for granted, taste is a complex chemical sense that allows us to perceive the flavors of food and drink, guiding our dietary choices and protecting us from ingesting harmful substances. The calm cosmos, in its diverse chemical compositions, is tasted and interpreted by our gustatory system. Our sense of taste is mediated by taste buds, which are located primarily on our tongue, but also on the roof of our mouth and in our throat. Each taste bud contains a cluster of taste receptor cells, each specialized to detect one of the 5 basic tastes: sweet, sour, salty, bitter, and umami, savory. When we eat, chemicals from the food dissolve in our saliva and bind to these taste receptor cells, triggering a neural signal that is sent to the brain. The calm cosmos, in its chemical diversity, is meticulously mapped by these specialized taste receptors. Sweetness is typically associated with sugars and other carbohydrates, providing a signal of energy-rich food. Sourness is associated with acids, which can indicate spoilage or unripe fruit. Saltiness is associated with sodium and other mineral salts, which are essential for maintaining our body's fluid balance. Bitterness is often associated with toxins and poisons, serving as a warning signal to avoid potentially harmful substances. Umami is associated with glutamate and other amino acids, signaling the presence of protein. The calm cosmos, in its nutritional diversity, is categorized and interpreted by our sense of taste. Our perception of flavor is not just about taste. It is a multisensory experience that also involves our sense of smell or olfaction. When we chew food, volatile chemicals are released and travel up to our nasal cavity, where they are detected by olfactory receptors. This information is then combined with the taste information from our tongue to create the rich and complex perception of flavor. This is why food often tastes bland when we have a cold and our sense of smell is impaired. The calm cosmos, in its complex sensory input, creates a unified perception of flavor. Beyond the 5 basic tastes, there is growing evidence for other taste qualities, such as fattiness, kokumi, a sense of richness or heartiness, and even a taste for water. This suggests that our gustatory system is even more complex and sophisticated than previously thought, capable of detecting a wide range of chemical cues that are important for our survival and well-being. The calm cosmos, in its chemical complexity, continues to reveal new dimensions of our sensory experience. Let's now delve into the equally fascinating world of our sense of smell or olfaction. While often considered less important than sight or hearing in humans, our sense of smell is a powerful and evocative sense that plays a crucial role in our perception of flavor, our emotional responses, and our social interactions. The calm cosmos, in its aromatic diversity, is perceived and interpreted by our olfactory system. Our sense of smell is mediated by olfactory receptor neurons, which are located in a small patch of tissue high up in our nasal cavity called the olfactory epithelium. These neurons have specialized receptors that bind to specific odorant molecules in the air we breathe. Humans have about 400 different types of olfactory receptors, which, in combination, allow us to distinguish between trillions of different odors. The calm cosmos, in its aromatic complexity, is meticulously mapped by these diverse olfactory receptors. When an odorant molecule binds to an olfactory receptor, it triggers a neural signal that is sent to the olfactory bulb, a structure at the base of the brain. From there, the information is relayed to other brain regions, including the piriform cortex, which is involved in identifying odors, and the limbic system, which is involved in emotion and memory. This direct connection to the limbic system is why smells can trigger such strong emotional responses and vivid memories. The calm cosmos, in its aromatic cues, can evoke powerful emotional and mnemonic experiences. Our sense of smell is not just about perceiving pleasant or unpleasant odors, it also plays a vital role in our survival. For example, the smell of smoke can alert us to a fire, and the smell of spoiled food can prevent us from eating something that could make us sick. Our sense of smell also plays a role in our social interactions, influencing our choice of partners and our ability to recognize family members. The calm cosmos, in its subtle chemical signals, influences our social and survival behaviors. Let's now explore the intriguing phenomenon of synesthesia, a condition where stimulation of one sensory or cognitive pathway leads to automatic, involuntary experiences in a second sensory or cognitive pathway. For example, a person with synesthesia might see colors when they hear music, or taste shapes when they read words. This blending of the senses provides a fascinating glimpse into the interconnectedness of our sensory systems and the remarkable plasticity of the human brain. The calm cosmos, in its complex sensory input, can be perceived in extraordinary and blended ways. Synesthesia is not a disease or a disorder. It is simply a different way of perceiving the world. It is thought to be caused by cross-activation between different brain regions that are normally separated. For example, in grapheme color synesthesia, where letters and numbers are perceived as having specific colors, there is evidence of increased connectivity between the brain regions responsible for processing letters and colors. The calm cosmos, in its intricate neural wiring, can create unique and blended sensory experiences. There are many different types of synesthesia, each involving a unique combination of senses. Some of the most common types include grapheme color synesthesia, chromesthesia, seeing colors in response to sounds, and lexical gustatory synesthesia, tasting words. The specific associations between senses are highly individual and consistent over time. For example, a person with grapheme color synesthesia will always perceive the letter A as the same color. The calm cosmos, in its diverse human experiences, manifests this phenomenon in a multitude of forms. Synesthesia is not just a curiosity, it can also have cognitive benefits. For example, some studies have shown that synesthetes have better memory and are more creative than non-synesthetes. This suggests that the cross-activation between brain regions might enhance certain cognitive abilities. The calm cosmos, in its diverse cognitive architectures, can lead to unique and enhanced abilities. In conclusion, while our 5 traditional senses provide us with a rich and vibrant experience of the world, they are just the tip of the iceberg. Beneath the surface lies a fascinating realm of hidden senses, constantly working in the background to gather information about our internal and external environments. From proprioception and interoception to thermoception and nociception, and even the more speculative magnetoreception and electroception, these subtle channels of perception play a crucial role in our survival, well-being, and our overall experience of the calm cosmos. As we continue to explore and understand these hidden senses, we gain a deeper appreciation for the incredible complexity and sophistication of the human body, and the profound ways in which we are connected to the universe around us. The silent, vast expanse of space, it turns out, is not just a realm of stars and galaxies, but a profound teacher, constantly revealing the subtle yet immense power of perception, the ultimate sculptor of our reality. Let's delve deeper into the fascinating realm of cognitive biases, which are systematic errors in thinking that affect the decisions and judgments that people make. These biases are not a sign of irrationality, but rather a consequence of our brain's attempt to simplify complex information and make quick decisions. They are powerful architects of our perceived reality, often leading us to interpret information in ways that confirm our existing beliefs, even if those interpretations are not objectively accurate. The calm cosmos, in its intricate design, has equipped us with cognitive shortcuts that can both help and hinder our understanding of reality. One of the most pervasive cognitive biases is confirmation bias, the tendency to search for, interpret, favor, and recall information in a way that confirms one's pre-existing beliefs or hypotheses. If we believe something to be true, we are more likely to notice and remember evidence that supports that belief, while ignoring or downplaying evidence that contradicts it. This creates a self-reinforcing loop, where our beliefs become more entrenched over time, making it difficult to consider alternative perspectives. For example, if someone believes that a particular political party is inherently corrupt, they will be more likely to seek out news stories and anecdotes that confirm this belief and dismiss any information that suggests otherwise. The calm cosmos, in its vast information landscape, is filtered through the lens of our existing beliefs. Another powerful bias is the availability heuristic, which is the tendency to overestimate the likelihood of events that are more easily recalled from memory. If we can easily think of examples of something, we tend to believe it is more common or more likely to occur. For instance, after seeing news reports about plane crashes, people might overestimate the risk of flying, even though statistically air travel is incredibly safe. This bias highlights how our personal experiences and the information we are exposed to can disproportionately influence our perception of reality. The calm cosmos, in its constant flow of information, is often interpreted based on what is most readily accessible to our minds. Anchoring bias is the tendency to rely too heavily on the first piece of information offered, the anchor, when making decisions. Once an anchor is set, subsequent judgments are made by adjusting away from that anchor, and there is a bias toward interpreting other information around the anchor. For example, in a negotiation, the first offer made can significantly influence the final price, even if that offer is arbitrarily high or low. This demonstrates how initial impressions and arbitrary numbers can subtly shape our perception of value and reality. The calm cosmos, in its economic systems, is often influenced by these subtle cognitive anchors. Framing effect is another significant bias, where people react to a particular choice in different ways depending on how it is presented. For example, a medical treatment might be perceived differently if it is described as having a 90% success rate versus a 10% failure rate, even though the objective outcome is the same. This highlights how the way information is framed can significantly alter our perception and decision-making, demonstrating the subjective nature of reality. The calm cosmos, in its complex narratives, is often shaped by the way information is presented. The Dunning-Kruger effect is a cognitive bias in which people with low ability at a task overestimate their ability, and highly skilled people underestimate their ability. This often leads to individuals with limited knowledge or expertise confidently asserting their views, while those with deeper understanding may be more hesitant. This bias can contribute to the spread of misinformation and make it challenging to engage in productive discussions, as individuals may be operating from fundamentally different perceived realities. The calm cosmos, in its pursuit of knowledge, is sometimes hindered by the illusion of competence. These cognitive biases are not flaws in our thinking, but rather evolutionary adaptations that helped our ancestors make quick decisions in uncertain environments. However, in the complex and information-rich modern world, they can lead to significant distortions in our perception of reality. Recognizing these biases is the first step towards mitigating their influence and fostering a more accurate and nuanced understanding of the world. The calm cosmos, in its intricate design, has equipped us with cognitive shortcuts that can both help and hinder our understanding of reality. Let's now turn our attention to the fascinating concept of social construction of reality, which posits that our understanding of the world is not solely based on objective facts, but is heavily influenced by social interactions, cultural norms, and shared agreements. This perspective suggests that many aspects of what we consider to be real are, in fact, products of human society and collective belief. The calm cosmos, in its social fabric, is woven with threads of shared meaning and interpretation. Consider the concept of gender. While biological sex is rooted in observable biological differences, gender is a social construct that varies across cultures and historical periods. What it means to be masculine or feminine, the roles and expectations associated with each, are not inherent but are shaped by societal norms, cultural values, and individual interpretations. This demonstrates how even fundamental aspects of identity can be socially constructed, highlighting the fluid and dynamic nature of reality. The calm cosmos, in its diverse human expressions, reveals the power of social construction in shaping identity. Money is another powerful example of a social construct. A piece of paper or a digital entry has no inherent value, yet we collectively agree to assign it value, and this shared belief makes it a powerful force in our lives. The entire global economy operates on this shared illusion of value, demonstrating how collective agreement can create a tangible and influential reality. The calm cosmos, in its economic systems, is built upon shared illusions of value. Even our understanding of emotions can be socially constructed. While basic emotions like happiness, sadness, and anger might have universal physiological components, the way we express, interpret, and categorize emotions can vary significantly across cultures. For example, some cultures might have words for emotions that do not exist in other languages, or they might express emotions in ways that are not easily understood by outsiders. This suggests that our emotional landscape, while deeply personal, is also shaped by the social and cultural context in which we live. The calm cosmos, in its emotional spectrum, is interpreted through diverse cultural lenses. The social construction of reality also extends to scientific knowledge. While science aims for objectivity, the questions scientists ask, the methods they use, and the interpretations they draw are all influenced by the prevailing social and cultural contexts. Scientific paradigms, or dominant frameworks of thought, shape how research is conducted and how findings are interpreted. When a paradigm shifts, it can fundamentally alter our understanding of reality, demonstrating the dynamic and evolving nature of scientific truth. The calm cosmos, in its scientific endeavors, is constantly being reinterpreted through new paradigms. This perspective does not deny the existence of an objective reality, but rather emphasizes that our access to it is always mediated by our social and cultural lenses. It suggests that what we perceive as truth is often a product of shared agreements, collective narratives, and historical contingencies. Recognizing the social construction of reality can foster greater empathy, understanding, and critical thinking, allowing us to question assumptions and appreciate the diversity of human experience. The calm cosmos, in its vast human tapestry, is woven with countless threads of shared meaning and interpretation. Let's now turn our attention to the fascinating concept of simulated reality, a hypothesis that suggests our entire universe, including ourselves, might be a sophisticated computer simulation. This idea, popularized by philosophers and scientists alike, challenges our fundamental assumptions about the nature of existence and raises profound questions about the true nature of reality. The calm cosmos, in its intricate design, might be a grand cosmic program running on an unimaginable supercomputer. The simulation hypothesis is often rooted in the rapid advancements in computing power and virtual reality technology. If we can create increasingly realistic simulations of worlds and consciousness within our own technological capabilities, it stands to reason that a sufficiently advanced civilization in the future might be able to create simulations that are indistinguishable from reality. If such simulations are possible, and if there are many more simulated realities than base realities, then the statistical probability suggests that we are more likely to be living in a simulation than in a base reality. The calm cosmos, in its technological trajectory, points towards the possibility of simulated existence. One of the key arguments for the simulation hypothesis comes from the fine-tuning of the universe. The fundamental physical constants, such as the strength of gravity, the mass of electrons, and the speed of light, appear to be precisely tuned for the emergence of life. If these constants were even slightly different, the universe would be a barren wasteland. Proponents of the simulation hypothesis suggest that this fine-tuning could be evidence that our universe was designed or programmed with specific parameters to allow for the development of complex life. The calm cosmos, in its apparent design, might be a carefully crafted simulation. Another intriguing aspect is the concept of glitches in the matrix, or anomalies that might suggest the simulated nature of our reality. While often dismissed as observational errors or misinterpretations, some phenomena such as quantum indeterminacy or the limits of the speed of light have been interpreted by some as evidence of computational constraints within a simulation. For example, the probabilistic nature of quantum mechanics could be a way for the simulation to save computational resources by only rendering reality when it is observed. The calm cosmos, in its subtle anomalies, might be revealing the underlying code of its existence. However, the simulation hypothesis also faces significant challenges and criticisms. How would we ever prove or disprove such a hypothesis? If the simulation is perfect, then any evidence we find within it would also be part of the simulation, making it impossible to distinguish from a base reality. Furthermore, the hypothesis raises an infinite regress problem. If we are in a simulation, then the civilization that created our simulation might also be in a simulation, and so on, leading to an endless chain of simulated realities. The calm cosmos, in its philosophical depths, presents us with questions that may transcend our ability to answer. Despite these challenges, the simulation hypothesis serves as a powerful thought experiment, forcing us to question our assumptions about reality and to consider alternative possibilities. It encourages us to explore the fundamental nature of consciousness, the limits of computation, and the very definition of existence. The calm cosmos, in its speculative possibilities, invites us to contemplate the ultimate nature of our reality. Let's now consider the profound implications of neuroscience for our understanding of reality. Our brains are not passive receivers of information, but active constructors of our perceived world. Every sight, sound, smell, taste, and touch we experience is not a direct reflection of external reality, but a complex electrochemical interpretation generated by our neural networks. The calm cosmos, in its intricate neural wiring, creates our subjective experience of reality. Consider the phenomenon of hallucination. In conditions like schizophrenia, or under the influence of certain substances, individuals can experience vivid perceptions that are not present in the external world. These hallucinations feel incredibly real to the person experiencing them, demonstrating the brain's capacity to generate reality from within, independent of external sensory input. This highlights the brain's role as a powerful reality generator, capable of creating experiences that are indistinguishable from those derived from external stimuli. The calm cosmos, in its neural symphony, can create realities that are both internal and external. Our brains also actively filter and organize the vast amount of sensory information we receive. If we were to consciously process every single piece of data entering our sensory organs, we would be overwhelmed. Instead, our brains prioritize and select information that is relevant to our goals and survival, effectively creating a simplified and manageable version of reality. This filtering process is largely unconscious, meaning that much of the information in our environment never even reaches our conscious awareness. The calm cosmos, in its information overload, is selectively perceived by our filtering brains. The phenomenon of change blindness further illustrates this point. we often fail to notice significant changes in our visual environment if our attention is directed elsewhere. For example, in experiments, people often fail to notice a person changing their clothes or an object disappearing from a scene if there is a brief interruption in their visual perception. This demonstrates that our brains do not create a complete and detailed representation of the entire visual field, but rather focus on what is deemed important, creating an illusion of continuous and comprehensive perception. The calm cosmos, in its subtle shifts, can go unnoticed by our selective attention. Our brains also create a sense of continuity and coherence in our experience, even though the underlying neural processes are discrete and fragmented. For example, our visual perception is not a continuous stream, but a series of rapid eye movements called saccades, interspersed with brief fixations. Yet we perceive a smooth and continuous visual world. Our brains stitch together these fragmented snapshots, creating an illusion of seamless perception. The calm cosmos in its fragmented data is unified by the brain into a coherent narrative. Furthermore, our brains are constantly making predictions about the world based on our past experiences and learned patterns. These predictions influence how we interpret incoming sensory information. If our predictions are accurate, our brains confirm them, reinforcing our existing models of reality. If our predictions are inaccurate, our brains update their models, leading to a revised understanding of reality. This predictive coding framework suggests that perception is not just about receiving information, but about actively generating and testing hypotheses about the world. The calm cosmos, in its predictive nature, is constantly being anticipated and interpreted by our brains. In conclusion, the insights from neuroscience reveal that our perceived reality is not a direct reflection of an objective external world, but a dynamic and highly personalized construction generated by our brains. This understanding does not diminish the richness of our experience, but rather highlights the incredible complexity and creativity of the human mind. The calm cosmos, in its intricate neural wiring, creates our subjective experience of reality. Let's now explore the philosophical concept of solipsism, which is the idea that only one's own mind is sure to exist. It is an epistemological position that holds that knowledge of anything outside one's own mind is unsure. The calm cosmos, in its profound philosophical questions, challenges us to consider the limits of our knowledge and the nature of individual existence. While solipsism is rarely taken as a serious philosophical position in its extreme form, it serves as a powerful thought experiment that forces us to confront the subjective nature of our experience. If all we can ever truly know are our own perceptions, thoughts, and feelings, then how can we be certain that anything outside of our own mind truly exists? This question has puzzled philosophers for centuries and highlights the inherent difficulty in bridging the gap between subjective experience and objective reality. The calm cosmos, in its subjective interpretations, is coloured by our internal states. Solipsism is often contrasted with realism, which posits that an objective reality exists independently of our minds. Most people intuitively adopt a realist perspective, believing that the world they perceive is largely the same for everyone else. However, the insights from neuroscience, cognitive psychology, and quantum physics, as we've discussed, suggest that our perception of reality is far more subjective and constructed than we often assume, lending some credence to the underlying concerns of solipsism. The calm cosmos, in its philosophical debates, explores the boundaries between individual and shared reality. One of the main arguments against solipsism is the problem of other minds. If only my mind exists, then how do I explain the existence of other people who appear to have their own consciousness, thoughts, and feelings? While a solipsist could argue that other people are merely elaborate illusions within their own mind, this explanation often feels intuitively unsatisfying and leads to a very lonely and isolated view of the universe. The calm cosmos, in its social interactions, suggests a shared reality beyond individual minds. Another argument against solipsism comes from the consistency and predictability of the external world. If the world were merely a figment of my imagination, then why does it behave in such consistent and predictable ways, following physical laws that I did not create? The sun rises every morning, gravity pulls objects downwards, and the laws of physics appear to operate independently of my will. This suggests an underlying order and structure that exists beyond my individual consciousness. The calm cosmos, in its consistent laws, hints at an objective reality. Despite these arguments, solipsism remains a powerful philosophical tool for questioning our assumptions about reality. It encourages us to reflect on the nature of consciousness, the limits of our knowledge, and the profound mystery of existence. It reminds us that our perceived reality is always mediated by our own minds, and that the ultimate nature of the cosmos may forever remain beyond our complete grasp. The calm cosmos, in its profound philosophical questions, challenges us to consider the limits of our knowledge and the nature of individual existence. Let's now consider the concept of the hard problem of consciousness, a term coined by philosopher David Chalmers. This problem refers to the difficulty of explaining how physical processes in the brain give rise to subjective experience, or qualia. While neuroscience can explain how our brains process sensory information and generate behavior, it struggles to explain why these processes are accompanied by conscious feelings and sensations. The calm cosmos, in its deepest mysteries, holds the key to understanding the very nature of consciousness itself. The easy problems of consciousness, according to Chalmers, are those that can be explained by computational or neural mechanisms, such as how the brain processes sensory information, integrates it, and uses it to control behavior. These are complex but ultimately solvable problems. The hard problem, however, is about the subjective, qualitative feel of experience. What it is like to see the colour red, to feel pain, or to taste chocolate. Why isn't all this processing done in the dark without any inner experience? The calm cosmos, in its intricate neural wiring, creates our subjective experience of reality. Various theories have been proposed to address the hard problem, but none have gained universal acceptance. Some theories suggest that consciousness is an emergent property of complex neural networks, arising when a certain level of complexity is reached. Others propose that consciousness is a fundamental property of the universe, much like space, time, or mass, and that it cannot be reduced to physical processes. Still others suggest that consciousness is an illusion, a byproduct of our brain's narrative-building capabilities. The calm cosmos, in its philosophical depths, presents us with questions that may transcend our ability to answer. The hard problem of consciousness has profound implications for our understanding of reality. If consciousness is not merely a byproduct of physical processes, then it suggests that there is more to reality than just matter and energy. It opens up the possibility of non-physical aspects of existence, challenging a purely materialistic worldview. It also raises questions about the nature of free will, the possibility of artificial consciousness, and the ultimate purpose of our existence. The calm cosmos, in its boundless mysteries, whispers of realities far more complex and subjective than we often assume. Despite the challenges, the hard problem of consciousness continues to be a driving force in scientific and philosophical inquiry. It pushes us to explore the boundaries of our understanding, to develop new theories, and to devise innovative experiments. It reminds us that the universe is full of mysteries, and that our journey of discovery is far from over. The calm cosmos, in its profound depths, holds the ultimate secrets of existence, waiting to be unveiled by the curious minds of humanity. It is a testament to the power of human inquiry, a reminder that the more we learn about the universe, the more we realize how much more there is to discover and how deeply interconnected we are with the fundamental fabric of reality. Let's now explore the concept of virtual reality and augmented reality, and how these technologies are increasingly blurring the lines between what is real and what is simulated. As these technologies advance, they offer us a glimpse into a future where our perceived reality can be seamlessly altered, enhanced, or even entirely replaced by digital constructs. The calm cosmos, in its technological evolution, is creating new dimensions of perceived reality. Virtual reality, VR, immerses users in a completely simulated environment, often through the use of head-mounted displays that block out the physical world. In a well-designed VR experience, the user's senses are tricked into believing they are in a different place, interacting with virtual objects and characters as if they were real. This technology is already being used for training simulations, gaming, therapy, and even virtual tourism, allowing people to experience places and situations that would otherwise be inaccessible. The calm cosmos, in its digital manifestations, offers immersive experiences that challenge our traditional notions of presence. Augmented reality, AR, on the other hand, overlays digital information onto the real world, enhancing our perception of existing reality rather than replacing it. This can be done through smartphone apps, smart glasses, or other devices that project virtual objects or information into our field of view. For example, an AR app might allow you to see virtual furniture in your living room before you buy it, or an AR game might place digital characters in your physical environment. AR seamlessly blends the digital and physical worlds, creating a hybrid reality that is both familiar and enhanced. The calm cosmos, in its technological overlays, enriches our perception of the physical world. As VR and AR technologies become more sophisticated, the distinction between what is real and what is virtual will become increasingly difficult to discern. Haptic feedback systems can simulate the sensation of touch, olfactory devices can generate smells, and advanced graphics can create visuals that are indistinguishable from reality. This raises profound questions about the nature of our experience. If a virtual experience feels as real as a physical one, what then defines reality? The calm cosmos, in its technological advancements, pushes the boundaries of what we consider to be real. These technologies also have significant implications for our social interactions and personal identities. We can create virtual avatars that represent us in digital spaces, allowing us to experiment with different identities and appearances. We can interact with others in virtual worlds, forming relationships and communities that exist entirely within the digital realm. As more of our lives are lived in these blended realities, our understanding of self and society may undergo a fundamental transformation. The calm cosmos in its digital communities fosters new forms of social interaction and identity. Furthermore, the development of brain-computer interfaces, BCEs, promises an even more direct connection between our minds and digital realities. BCIS could potentially allow us to control virtual environments with our thoughts, or even to directly input sensory information into our brains, creating experiences that are indistinguishable from physical reality. This raises the possibility of a future where our entire perceived reality could be generated internally, blurring the lines between consciousness and computation. The calm cosmos, in its neural interfaces, hints at a future where reality is directly experienced through thought. However, these advancements also come with ethical considerations. Who controls these virtual realities? What are the implications for privacy and data security? How do we ensure that these technologies are used for the benefit of humanity rather than for manipulation or control? As we venture further into the realm of simulated and augmented realities, it becomes increasingly important to engage in thoughtful discussions about the societal implications of these powerful technologies. The calm cosmos, in its ethical dilemmas, challenges us to navigate the complexities of technological progress. Let's now consider the role of narrative and storytelling in shaping our perception of reality. Humans are inherently storytelling creatures. We make sense of the world by constructing narratives, both personal and collective. These stories provide meaning, coherence, and a framework for understanding our experiences, but they also filter and interpret reality in specific ways. The calm cosmos, in its grand narrative, is constantly being interpreted through human stories. Our personal narratives, the stories we tell ourselves about who we are, where we come from, and where we are going, profoundly influence our self-perception and our interactions with the world. These narratives are not static. They evolve over time, shaped by new experiences, reflections, and interactions with others. However, they also create a sense of continuity and identity, allowing us to navigate the complexities of life. The calm cosmos, in its individual journeys, is understood through the lens of personal narratives. Collective narratives, such as myths, religions, historical accounts, and cultural ideologies, provide a shared understanding of reality for groups and societies. These narratives define what is considered true, good, and important, shaping our values, beliefs, and social norms. They can inspire collective action, foster a sense of belonging, and provide comfort in times of uncertainty. However, they can also perpetuate biases, exclude alternative perspectives, and even justify conflict. The calm cosmos, in its diverse cultures, is interpreted through countless shared narratives. Storytelling is not just a form of entertainment. It is a fundamental cognitive process that helps us organize information, make predictions, and understand cause and effect. When we hear a story our brains actively engage in constructing a mental model of the events, filling in gaps and making inferences. This active engagement makes stories incredibly powerful tools for shaping beliefs and influencing behavior. The calm cosmos, in its intricate design, has equipped us with the capacity for narrative understanding. The media, in its various forms, plays a significant role in shaping our collective narratives and, consequently, our perception of reality. News reports, documentaries, films, and social media all contribute to the stories we tell ourselves about the world. The way events are framed, the language used, and the images presented can significantly influence how we interpret reality, highlighting the power of media in constructing our shared understanding. The calm cosmos, in its mediated representations, is often shaped by the narratives presented by the media. Furthermore, the rise of misinformation and disinformation in the digital age has underscored the fragility of our shared reality. When false narratives spread rapidly and widely, they can distort public perception, erode trust in institutions, and even destabilize societies. This highlights the critical importance of media literacy, critical thinking, and the ability to discern credible sources from unreliable ones. The calm cosmos, in its information age, challenges us to navigate a complex landscape of narratives. In conclusion, narrative and storytelling are not merely reflections of reality, but active shapers of it. They provide us with meaning, coherence, and a framework for understanding our experiences, but they also filter and interpret reality in specific ways. By recognizing the power of narratives, we can become more discerning consumers of information, more thoughtful creators of our own stories, and more appreciative of the diverse ways in which humanity makes sense of the calm cosmos. It is a testament to the human need for meaning, a reminder that our understanding of the universe is deeply intertwined with the stories we tell ourselves about it. Let's now delve into the philosophical concept of idealism, which posits that reality, or reality as we can know it, is fundamentally mental, mentally constructed, or otherwise immaterial. This stands in contrast to materialism or physicalism, which hold that reality is fundamentally physical. Idealism suggests that our perceptions and consciousness are not merely products of a physical brain, but are, in fact, the primary constituents of reality itself. The calm cosmos, in its profound philosophical questions, invites us to consider the possibility that mind is primary to matter. One of the most prominent proponents of idealism was the Irish philosopher George Berkeley, who famously argued, "Esse est percipi," to be is to be perceived. Berkeley contended that physical objects do not exist independently of a mind perceiving them. For him, what we call physical objects are simply collections of ideas or sensations in the mind. If a tree falls in a forest and no one is there to hear it, does it make a sound? For Berkeley, if there is no mind to perceive the sound, then there is no sound. This radical view challenges our intuitive understanding of an objective, independent world. The calm cosmos, in its philosophical debates, questions the independent existence of matter. Berkeley addressed the apparent continuity and consistency of the world, even when no human mind is perceiving it, by introducing the concept of God as the ultimate perceiver. For Berkeley, God's omnipresent mind continuously perceives all things, thus ensuring their existence and the regularity of natural laws. This divine perception provides the stability and objectivity that we experience in the world, even when individual human minds are not actively observing. The calm cosmos, in its divine perception, maintains its consistent reality. Another form of idealism is transcendental idealism, most famously articulated by Immanuel Kant. Kant argued that while there is an external reality, the noumenal world or things in themselves, we can never directly access it. Instead, our minds actively structure and organize our experiences through innate categories of understanding, such as space, time, causality, and substance. What we perceive as reality, the phenomenal world, is therefore a product of both the external world and the inherent structure of our minds. We don't just perceive reality, we constitute it. The calm cosmos, in its transcendental framework, is shaped by the inherent structures of our minds. Kant's philosophy suggests that the very concepts of space and time are not external features of the universe, but are forms of intuition, or ways in which our minds organize sensory data. We cannot conceive of objects existing outside of space and time because our minds are hardwired to perceive them in this manner. This means that the spatial and temporal dimensions of our reality are, in a fundamental sense, mental constructs. The calm cosmos, in its perceived dimensions, is organized by our innate cognitive structures. Idealism, in its various forms, challenges the common-sense notion of a purely objective material reality. It suggests that consciousness and perception are not merely epiphenomena of physical processes, but are central to the very nature of existence. This perspective has profound implications for our understanding of the universe, our place within it, and the ultimate nature of truth. The calm cosmos, in its philosophical depths, invites us to reconsider the fundamental relationship between mind and matter. Let's now turn our attention to the concept of the holographic universe, a speculative theory that suggests our three-dimensional reality might be an illusion, a projection from a two-dimensional surface, much like a hologram. This idea, drawing inspiration from both quantum physics and black hole thermodynamics, offers a radical new way of thinking about the fundamental nature of space, time, and information. The calm cosmos, in its intricate design, might be a grand cosmic hologram. The holographic principle emerged from the study of black holes. Physicists like Jacob Bekenstein and Stephen Hawking discovered that the entropy, a measure of disorder or information, of a black hole is proportional not to its volume, but to the area of its event horizon, the boundary beyond which nothing, not even light, can escape. This was a surprising finding, as it suggested that the information contained within a three-dimensional volume could be encoded on a two-dimensional surface. This led to the idea that the universe might be like a giant hologram, where all the information about our three-dimensional reality is encoded on a distant two-dimensional boundary. The calm cosmos, in its informational paradoxes, hints at a deeper, more fundamental structure. One of the most compelling arguments for the holographic universe comes from string theory, a theoretical framework that attempts to unify all fundamental forces of nature. Within certain versions of string theory, particularly the anti-de Sitter/conformal field theory, ADS/CFT, correspondence, there is a mathematical duality between a gravitational theory in a higher dimensional spacetime and a quantum field theory without gravity in a lower dimensional spacetime. This correspondence suggests that a universe with gravity in 3 dimensions could be mathematically equivalent to a universe without gravity in 2 dimensions, implying a holographic relationship. The calm cosmos, in its theoretical elegance, might be described by a holographic duality. If our universe is indeed a hologram, it would mean that the seemingly solid, 3-dimensional objects and events we experience are merely projections, much like the images projected from a holographic plate. The true reality, the fundamental information, would reside on a distant 2-dimensional surface. This would profoundly alter our understanding of space and time, suggesting that they are not fundamental properties of reality, but emergent phenomena arising from the holographic projection. The calm cosmos, in its illusory dimensions, might be a projection from a more fundamental reality. The holographic universe theory also offers potential solutions to some of the long-standing paradoxes in physics, such as the black hole information paradox. If information is encoded on the event horizon, then it is never truly lost when matter falls into a black hole, thus preserving the fundamental principle of information conservation in quantum mechanics. The calm cosmos, in its theoretical solutions, might resolve some of the deepest mysteries of physics. However, the holographic universe theory is still highly speculative and faces significant challenges. It is primarily a theoretical framework, and direct experimental evidence is scarce. Furthermore, the exact nature of the 2-dimensional surface and how information is encoded and projected remains largely unknown. Despite these challenges, the holographic universe theory serves as a powerful conceptual tool, pushing the boundaries of our imagination and encouraging us to question our most fundamental assumptions about reality. The calm cosmos, in its speculative possibilities, invites us to contemplate the ultimate nature of our reality. Let's now consider the profound implications of the concept of consciousness for our understanding of reality. While we have touched upon the hard problem of consciousness earlier, let's explore how different theories of consciousness directly impact our perception of what is real. The calm cosmos, in its deepest mysteries, holds the key to understanding the very nature of consciousness itself. One perspective is that consciousness is an emergent property of complex physical systems, specifically the brain. In this view, consciousness arises from the intricate interactions of billions of neurons and their electrochemical signals. It is seen as a sophisticated computational process, and once the brain reaches a certain level of complexity, consciousness simply emerges. If this is true, then reality is fundamentally physical, and consciousness is a product of that physical reality. The calm cosmos, in its intricate neural wiring, creates our subjective experience of reality. However, another perspective, often associated with panpsychism, suggests that consciousness is a fundamental property of the universe, present in some form at all levels of reality, from subatomic particles to galaxies. In this view, consciousness is not something that emerges from matter, but is an inherent aspect of matter itself. This doesn't mean that a rock is conscious in the same way a human is, but that it possesses some rudimentary form of proto-consciousness. If panpsychism is true, then reality is fundamentally conscious, and our individual consciousness is a localized manifestation of this universal consciousness. The calm cosmos, in its pervasive consciousness, suggests a universe that is alive with awareness. Integrated Information Theory, IIT, proposed by Giulio Tononi, is a prominent theory that attempts to quantify consciousness. IIT suggests that consciousness is related to the amount of integrated information a system possesses, meaning how much information is generated by the system as a whole that cannot be reduced to the information generated by its individual parts. The more integrated information a system has, the more conscious it is. This theory provides a mathematical framework for understanding consciousness and suggests that consciousness is not an all-or-nothing phenomenon, but exists on a spectrum. The calm cosmos, in its informational complexity, might be understood through the lens of integrated information. Another intriguing idea is that consciousness is not localized to the brain, but is distributed throughout the universe. This view, often found in spiritual and mystical traditions, suggests that our individual consciousness is merely a small part of a larger universal consciousness. In this framework, the illusion of reality arises from our limited perception, our inability to fully grasp the interconnectedness of all things. The calm cosmos, in its boundless unity, suggests a consciousness that transcends individual minds. The implications of these theories for our understanding of reality are profound. If consciousness is fundamental, then reality itself might be fundamentally mental or experiential. If consciousness is emergent, then reality is fundamentally physical, and consciousness is a product of that physical reality. The ongoing debate about the nature of consciousness continues to shape our understanding of what is real and how we interact with it. The calm cosmos, in its deepest mysteries, holds the key to understanding the very nature of consciousness itself. Let's now explore the concept of the observer effect in quantum mechanics and its philosophical implications for the nature of reality. While we briefly touched upon it earlier, let's delve deeper into how the act of observation seems to influence the behavior of particles at the quantum level, and what this might mean for the objective existence of reality. The calm cosmos, in its quantum depths, challenges the very notion of an objective reality independent of observation. In classical physics, observation is assumed to be a passive act. Measuring a property of a system does not affect the system itself. However, at the quantum scale, this assumption breaks down. The very act of observing or measuring a quantum particle can influence its state. This is not due to the disturbance caused by the measuring instrument, but rather a fundamental aspect of quantum reality. The calm cosmos, in its quantum weirdness, suggests a universe where observation is an active participant in shaping reality. The double-slit experiment, as mentioned before, is the quintessential demonstration of the observer effect. When particles are not observed, they behave like waves, creating an interference pattern. But when detectors are placed at the slits to determine which path the particles take, the interference pattern disappears, and the particles behave like discrete particles. It's as if the particles know they are being watched and change their behavior accordingly. This phenomenon has led to various interpretations, some of which suggest a direct link between consciousness and the collapse of the wave function. The calm cosmos, in its quantum paradoxes, hints at a deeper connection between mind and matter. One interpretation, the Copenhagen interpretation, suggests that a quantum system exists in a superposition of all possible states until it's measured, at which point the wave function collapses, and the system settles into a single definite state. The act of measurement or observation is what brings reality into being. This doesn't necessarily imply that a conscious observer is required, but rather that any interaction with the system that extracts information about its state can cause the collapse. The calm cosmos, in its probabilistic nature, is realized through interaction. Another interpretation, the many-worlds interpretation, proposes that every time a quantum measurement is made, the universe splits into multiple parallel universes, each representing a different possible outcome of the measurement. In this view, the wave function never truly collapses. Instead, all possible outcomes are realized in different branches of the universe. This interpretation avoids the need for an observer to collapse the wave function, but introduces an infinite number of parallel realities. The calm cosmos, in its branching possibilities, suggests a multiverse of realities. The observer effect raises profound philosophical questions about the nature of reality. If reality is not fixed until it is observed, then what does it mean for something to exist independently of our perception? Does a tree falling in a forest truly make a sound if no one is there to hear it, even if we extend observer to include non-conscious interactions? These questions challenge our intuitive understanding of an objective, independent world and suggest that reality might be more fluid and participatory than we imagine. The calm cosmos, in its quantum mysteries, invites us to reconsider the fundamental relationship between observer and observed. While the observer effect is a well-established phenomenon in quantum mechanics, its philosophical implications are still debated. Some argue that it only applies to the quantum realm and does not extend to our macroscopic world, where objects appear to have definite properties regardless of observation. Others suggest that it hints at a deeper interconnectedness between consciousness and the fabric of reality, blurring the lines between the subjective and the objective. The calm cosmos, in its profound depths, holds the ultimate secrets of existence, waiting to be unveiled by the curious minds of humanity. It is a testament to the power of human inquiry, a reminder that the more we learn about the universe, the more we realize how much more there is to discover, and how deeply interconnected we are with the fundamental fabric of reality. Let's now explore the intricate relationship between time and our perception of reality. While time often feels like an objective, linear progression, both physics and psychology suggest that our experience of time is far more subjective and fluid than we commonly assume. The calm cosmos, in its temporal dimensions, reveals a reality where time is not always what it seems. From a psychological perspective, our perception of time can be highly elastic. Time seems to speed up when we are engaged in enjoyable activities and slow down when we are bored or in pain. This phenomenon, known as time dilation in subjective experience, is influenced by factors such as attention, emotion, and memory. For example, during a traumatic event, time can appear to stretch out, with every detail unfolding in slow motion. Conversely, a familiar routine can pass by in a blur as our brains process less new information. The calm cosmos, in its subjective temporal flows, is shaped by our internal states. Our memory also plays a crucial role in our perception of time. We tend to remember novel and emotionally significant events more vividly, making those periods feel longer in retrospect. Conversely, periods of routine or monotony tend to compress in our memory, making them feel shorter. This means that our personal timeline is not a perfectly accurate record of objective duration, but a reconstructive narrative influenced by the salience of our experiences. The calm cosmos, in its narrative constructions, reveals the brain's tireless effort to create meaning. From a physics perspective, Albert Einstein's theories of relativity revolutionized our understanding of time, demonstrating that it is not an absolute universal constant, but is relative to the observer's motion and gravitational field. Special relativity showed that time can pass at different rates for observers, moving at different speeds. The faster an object moves, the slower time passes for it relative to a stationary observer. This phenomenon, known as time dilation, has been experimentally verified with atomic clocks on airplanes and satellites. The calm cosmos, in its relativistic speeds, reveals the elasticity of time. General relativity further expanded this concept, demonstrating that gravity also affects the passage of time. Time passes more slowly in stronger gravitational fields. This means that time passes slightly slower for someone at sea level than for someone on top of a mountain, and significantly slower near massive objects like black holes. This gravitational time dilation is a crucial factor that must be accounted for in technologies like GPS, which rely on precise timing from satellites orbiting Earth. The calm cosmos, in its gravitational wells, bends the fabric of space-time. These relativistic effects suggest that time is not a separate dimension through which we move, but is intimately interwoven with space, forming a unified fabric called space-time. Events do not simply happen in time, but are part of a four-dimensional space-time continuum. This challenges our intuitive notion of a universal now, and suggests that past, present, and future might coexist in some fundamental sense. The calm cosmos, in its space-time continuum, presents a reality where all moments are interconnected. Furthermore, some theories in quantum gravity, such as loop quantum gravity, suggest that time might not be fundamental at all, but an emergent property of the universe. In these theories, time arises from the relationships and interactions between fundamental constituents of reality, rather than being a pre-existing backdrop. This radical idea implies that at the most fundamental level, there might be no such thing as time, and our experience of it is an emergent illusion. The calm cosmos, in its quantum depths, whispers of realities far more complex and subjective than we often assume. In conclusion, our perception and the physical nature of time are far more complex and subjective than our everyday experience suggests. From psychological elasticity to relativistic dilation and quantum emergence, time is revealed to be a dynamic and interwoven aspect of reality, constantly shaped by our internal states and the fundamental laws of the universe. The calm cosmos, in its temporal mysteries, invites us to reconsider the very nature of existence and our place within its ever-unfolding narrative. Let's now explore the concept of the simulation hypothesis in greater detail, moving beyond its initial premise to consider its profound implications for our understanding of consciousness, free will, and the very purpose of existence. If our reality is indeed a sophisticated computer simulation, then the nature of our being and our place in the cosmos take on an entirely new dimension. The calm cosmos, in its intricate design, might be a grand cosmic program running on an unimaginable supercomputer. One of the most intriguing implications of the simulation hypothesis is the question of consciousness. If we are simulated beings, is our consciousness also simulated? And if so, does that diminish its reality or significance? Some argue that if a simulated consciousness is indistinguishable from a biological one, then it is equally real. The subjective experience of being conscious, the qualia of seeing red or feeling pain, would be just as vivid and authentic within a simulation as in a base reality. This suggests that the nature of consciousness might be independent of its substrate, whether it's biological neurons or digital code. The calm cosmos, in its digital manifestations, offers immersive experiences that challenge our traditional notions of presence. Another critical question is that of free will. If our actions and choices are determined by the code of a simulation, do we truly have free will, or are we merely following a predetermined script? This is a long-standing philosophical debate, but the simulation hypothesis adds a new layer of complexity. If our universe is a simulation, then the programmers could potentially manipulate our experiences, alter the laws of physics, or even reset the simulation. This raises concerns about the extent of our autonomy and the true nature of our agency. The calm cosmos, in its simulated possibilities, challenges the very notion of free will. Furthermore, the simulation hypothesis opens up profound questions about the purpose of our existence. If we are part of a simulation, what is its purpose? Are we part of an experiment, a historical recreation, a game, or a training program for the base reality inhabitants? This shifts the focus from an intrinsic purpose within our universe to an extrinsic purpose determined by the simulators. It could lead to a re-evaluation of our values, our goals, and our understanding of meaning. The calm cosmos, in its grand cosmic program, might have an ultimate purpose beyond our current comprehension. The concept of meta-simulation also arises from this hypothesis. If we can simulate realities, then the beings in the base reality might also be simulated, leading to an infinite regress of simulations within simulations. This raises the question of whether there is an ultimate fundamental reality, or if reality is an endless fractal of simulated layers. The calm cosmos, in its infinite regress, presents us with questions that may transcend our ability to answer. The simulation hypothesis also has implications for our understanding of scientific discovery. If our universe is a simulation, then the laws of physics we discover might simply be the algorithms or rules programmed into the simulation. Anomalies or unexplained phenomena could be bugs or glitches in the code. This perspective could provide a new framework for scientific inquiry, encouraging us to look for patterns and inconsistencies that might reveal the underlying computational nature of our reality. The calm cosmos, in its subtle anomalies, might be revealing the underlying code of its existence. However, it's important to reiterate that the simulation hypothesis remains a speculative idea. There is no definitive scientific evidence to prove or disprove it. Yet its power lies in its ability to provoke thought, to challenge our assumptions, and to encourage us to look at our reality from a different perspective. It forces us to consider the possibility that the universe is far more extraordinary and mysterious than we can currently comprehend. The calm cosmos, in its speculative possibilities, invites us to contemplate the ultimate nature of our reality. Let's now delve into the fascinating intersection of consciousness, reality, and the concept of flow states. Flow, a term coined by psychologist Mihaly Csikszentmihalyi, describes a mental state in which a person performing an activity is fully immersed in a feeling of energized focus, full involvement, and enjoyment in the process of the activity. In essence, flow is characterized by complete absorption in what one does and a resulting transformation in one's sense of time. The calm cosmos, in its moments of profound engagement, reveals a heightened and altered state of reality. During a flow state, individuals often report a distorted sense of time, where hours can feel like minutes, or vice versa. This subjective time dilation or compression highlights how our internal experience of time can deviate significantly from objective clock time. This is not merely a psychological trick, but a profound alteration in our perception of reality, where the boundaries between self and activity dissolve and the external world fades into the background. The calm cosmos, in its temporal elasticity, is shaped by our internal states of focus. Another characteristic of flow is a sense of effortless action and a feeling of being in control. Despite the challenge of the task, the individual feels a sense of mastery and competence, with actions flowing seamlessly from one to the next. This feeling of control contributes to a heightened sense of agency and a belief in one's ability to influence outcomes, further shaping their perceived reality. The calm cosmos, in its moments of mastery, empowers us to shape our own experience. Flow states are often achieved when there is a clear balance between the perceived challenges of a task and one's perceived skills. If the challenge is too low, boredom sets in. If the challenge is too high, anxiety arises. But when the challenge is just right and one's skills are adequately matched, the conditions for flow are ripe. This suggests that our engagement with reality and our subjective experience of it is optimized when we're operating at the edge of our capabilities. The calm cosmos, in its optimal challenges, invites us to grow and expand our abilities. The experience of flow is intrinsically rewarding. The activity itself becomes the reward rather than any external outcome. This intrinsic motivation is a powerful driver of human behavior and learning. When we are in flow, we are not driven by external incentives, but by the sheer joy and satisfaction of the activity itself. This suggests that the most fulfilling experiences of reality are those where we are deeply engaged and absorbed in the present moment. The calm cosmos, in its intrinsic rewards, offers profound satisfaction through deep engagement. Flow states have been observed across a wide range of activities, from sports and artistic creation to scientific research and everyday tasks. A surgeon performing a complex operation, a musician improvising a jazz solo, a writer engrossed in their craft, or a gardener tending to their plants can all experience flow. This universality suggests that the capacity for flow is an inherent human potential, a pathway to a more engaged and fulfilling experience of reality. The calm cosmos, in its diverse activities, offers countless opportunities for profound engagement. In conclusion, the concept of flow states provides a powerful lens through which to understand the subjective and transformative nature of our perceived reality. It highlights how deep engagement, optimal challenge, and a distorted sense of time can lead to heightened experiences of consciousness and a profound sense of well-being. The calm cosmos, in its moments of profound engagement, reveals a heightened and altered state of reality, inviting us to seek out and cultivate these experiences in our daily lives. It is a testament to the human capacity for absorption, a reminder that the most vivid and meaningful aspects of our reality are often found when we are fully present and immersed in the unfolding moment. Let's now explore the philosophical concept of phenomenalism, which asserts that physical objects are nothing more than bundles of sense data or sensory experiences. This view is closely related to idealism, but focuses specifically on the nature of physical objects and their relationship to our perceptions. Phenomenalism suggests that what we call reality is ultimately reducible to our experiences of it. The calm cosmos, in its sensory manifestations, is interpreted through the lens of our direct experiences. For a phenomenalist, a physical object like a table is not an independent entity existing apart from our perception. Instead, it is a collection of actual and possible sensations: the visual sensation of its brown colour and rectangular shape, the tactile sensation of its smoothness and hardness, the auditory sensation of a thud when something is placed on it, and so on. When we say the table exists, we mean that if we were to have certain sensory experiences, we would perceive the table. The calm cosmos, in its tangible forms, is a compilation of sensory data. This perspective challenges the common-sense notion of an external world that exists independently of any observer. If phenomenalism is true, then the existence of physical objects is contingent upon the possibility of being perceived. This doesn't necessarily mean that objects cease to exist when no one is looking at them, but rather that their existence is defined by their potential to produce sensory experiences. The calm cosmos, in its perceived existence, is defined by its potential to be experienced. Phenomenalism attempts to bridge the gap between our subjective experiences and the objective world. By reducing physical objects to sense data, it aims to eliminate the problem of how our minds can know an external world that is fundamentally different from our internal experiences. If the world is made of the same stuff as our perceptions, then the problem of knowledge becomes less daunting. The calm cosmos, in its epistemological challenges, seeks to reconcile internal and external realities. However, phenomenalism faces several criticisms. One major challenge is explaining the consistency and regularity of our sensory experiences. If physical objects are merely bundles of sense data, why do different observers tend to have similar experiences of the same object? And why do these experiences follow predictable patterns, adhering to the laws of physics? Phenomenalists might argue that this consistency is due to the inherent structure of our minds, or a shared framework of potential sensations. The calm cosmos, in its consistent patterns, suggests an underlying order beyond individual perceptions. Another criticism is the problem of unperceived objects. If a tree falls in a forest and no one is there to perceive it, does it still exist? For a strict phenomenalist, its existence would be defined by the possibility of perception. But this can lead to counterintuitive conclusions. Furthermore, how do we account for scientific discoveries about the universe that are far beyond human sensory capabilities, such as subatomic particles or distant galaxies? Phenomenalism struggles to fully incorporate these aspects of reality. The calm cosmos, in its unperceived vastness, challenges the limits of phenomenalist interpretation. Despite these challenges, phenomenalism serves as a powerful reminder of the central role of perception in shaping our understanding of reality. It encourages us to question our assumptions about the independent existence of the external world and to consider the profound ways in which our sensory experiences constitute our reality. The calm cosmos, in its philosophical depths, invites us to reconsider the fundamental relationship between mind and matter. Let's now explore the concept of the simulation hypothesis in greater detail, moving beyond its initial premise to consider its profound implications for our understanding of consciousness, free will, and the very purpose of existence. If our reality is indeed a sophisticated computer simulation, then the nature of our being and our place in the cosmos take on an entirely new dimension. The calm cosmos, in its intricate design, might be a grand cosmic program running on an unimaginable supercomputer. One of the most intriguing implications of the simulation hypothesis is the question of consciousness. If we are simulated beings, is our consciousness also simulated? And if so, does that diminish its reality or significance? Some argue that if a simulated consciousness is indistinguishable from a biological one, then it is equally real. The subjective experience of being conscious, the qualia of seeing red or feeling pain, would be just as vivid and authentic within a simulation as in a base reality. This suggests that the nature of consciousness might be independent of its substrate, whether it's biological neurons or digital code. The calm cosmos, in its digital manifestations, offers immersive experiences that challenge our traditional notions of presence. Another critical question is that of free will. If our actions and choices are determined by the code of a simulation, do we truly have free will, or are we merely following a predetermined script? This is a long-standing philosophical debate, but the simulation hypothesis adds a new layer of complexity. If our universe is a simulation, then the programmers could potentially manipulate our experiences, alter the laws of physics, or even reset the simulation. This raises concerns about the extent of our autonomy and the true nature of our agency. The calm cosmos, in its simulated possibilities, challenges the very notion of free will. Furthermore, the simulation hypothesis opens up profound questions about the purpose of our existence. If we are part of a simulation, what is its purpose? Are we part of an experiment, a historical recreation, a game, or a training program for the base reality inhabitants? This shifts the focus from an intrinsic purpose within our universe to an extrinsic purpose determined by the simulators. It could lead to a re-evaluation of our values, our goals, and our understanding of meaning. The calm cosmos, in its grand cosmic program, might have an ultimate purpose beyond our current comprehension. The concept of meta-simulation also arises from this hypothesis. If we can simulate realities, then the beings in the base reality might also be simulated, leading to an infinite regress of simulations within simulations. This raises the question of whether there is an ultimate, fundamental reality, or if reality is an endless fractal of simulated layers. The calm cosmos, in its infinite regress, presents us with questions that may transcend our ability to answer. The simulation hypothesis also has implications for our understanding of scientific discovery. If our universe is a simulation, then the laws of physics we discover might simply be the algorithms or rules programmed into the simulation. Anomalies or unexplained phenomena could be bugs or glitches in the code. This perspective could provide a new framework for scientific inquiry, encouraging us to look for patterns and inconsistencies that might reveal the underlying computational nature of our reality. The calm cosmos, in its subtle anomalies, might be revealing the underlying code of its existence. However, it's important to reiterate that the simulation hypothesis remains a speculative idea. There is no definitive scientific evidence to prove or disprove it. Yet, its power lies in its ability to provoke thought, to challenge our assumptions, and to encourage us to look at our reality from a different perspective. It forces us to consider the possibility that the universe is far more extraordinary and mysterious than we can currently comprehend. The calm cosmos, in its speculative possibilities, invites us to contemplate the ultimate nature of our reality. Let's now delve into the fascinating intersection of consciousness, reality, and the concept of flow states. Flow, a term coined by psychologist Mihaly Csikszentmihalyi, describes a mental state in which a person performing an activity is fully immersed in a feeling of energized focus, full involvement, and enjoyment in the process of the activity. In essence, flow is characterized by complete absorption in what one does and a resulting transformation in one's sense of time. The calm cosmos, in its moments of profound engagement, reveals a heightened and altered state of reality. During a flow state, individuals often report a distorted sense of time, where hours can feel like minutes, or vice versa. This subjective time dilation or compression highlights how our internal experience of time can deviate significantly from objective clock time. This is not merely a psychological trick, but a profound alteration in our perception of reality, where the boundaries between self and activity dissolve and the external world fades into the background. The calm cosmos, in its temporal elasticity, is shaped by our internal states of focus. Another characteristic of flow is a sense of effortless action and a feeling of being in control. Despite the challenge of the task, the individual feels a sense of mastery and competence, with actions flowing seamlessly from one to the next. This feeling of control contributes to a heightened sense of agency and a belief in one's ability to influence outcomes, further shaping their perceived reality. The calm cosmos, in its moments of mastery, empowers us to shape our own experience. Flow states are often achieved when there is a clear balance between the perceived challenges of a task and one's perceived skills. If the challenge is too low, boredom sets in. If the challenge is too high, anxiety arises. But when the challenge is just right and one's skills are adequately matched, the conditions for flow are ripe. This suggests that our engagement with reality and our subjective experience of it is optimized when we are operating at the edge of our capabilities. The calm cosmos, in its optimal challenges, invites us to grow and expand our abilities. The experience of flow is intrinsically rewarding. The activity itself becomes the reward rather than any external outcome. This intrinsic motivation is a powerful driver of human behavior and learning. When we are in flow, we are not driven by external incentives, but by the sheer joy and satisfaction of the activity itself. This suggests that the most fulfilling experiences of reality are those where we are deeply engaged and absorbed in the present moment. The calm cosmos, in its intrinsic rewards, offers profound satisfaction through deep engagement. Flow states have been observed across a wide range of activities, from sports and artistic creation to scientific research and everyday tasks. A surgeon performing a complex operation, a musician improvising a jazz solo, a writer engrossed in their craft, or a gardener tending to their plants can all experience flow. This universality suggests that the capacity for flow is an inherent human potential, a pathway to a more engaged and fulfilling experience of reality. The calm cosmos, in its diverse activities, offers countless opportunities for profound engagement. In conclusion, the concept of flow states provides a powerful lens through which to understand the subjective and transformative nature of our perceived reality. It highlights how deep engagement, optimal challenge, and a distorted sense of time can lead to heightened experiences of consciousness and a profound sense of well-being. The calm cosmos, in its moments of profound engagement, reveals a heightened and altered state of reality, inviting us to seek out and cultivate these experiences in our daily lives. It is a testament to the human capacity for absorption, a reminder that the most vivid and meaningful aspects of our reality are often found when we are fully present and immersed in the unfolding moment. Let's now explore the concept of the multiverse hypothesis and how it challenges our understanding of a single, objective reality. The idea that our universe is just one among an infinite number of parallel universes, each with its own unique set of physical laws, constants, and histories, profoundly alters our perception of what is real and possible. The calm cosmos, in its boundless possibilities, might be a mere speck in an infinitely larger cosmic tapestry. There are several theoretical frameworks that give rise to the multiverse concept. One is the inflationary multiverse, which stems from the theory of cosmic inflation. This theory suggests that immediately after the Big Bang, the universe underwent a period of extremely rapid expansion. If inflation is eternal, meaning it never truly ends everywhere, then it would continuously produce new bubble universes, each potentially with different physical properties. Our observable universe would then be just one such bubble, floating in a vast, ever-expanding ocean of other universes. The calm cosmos, in its inflationary origins, might be perpetually spawning new realities. Another type is the many worlds interpretation of quantum mechanics, which we touched upon earlier. This interpretation posits that every time a quantum measurement is made, the universe splits into multiple parallel universes, each representing a different possible outcome of the measurement. In this view, all possible realities are realized, and our perceived reality is just one branch of an infinitely branching cosmic tree. This means that every decision we make, every quantum event, creates new parallel universes, each with a slightly different version of reality. The calm cosmos, in its quantum branching, suggests a multitude of coexisting realities. The brain multiverse is another intriguing concept, derived from string theory. In this model, our universe is a three-dimensional brain, a membrane-like object, floating in a higher dimensional space, or bulk. Other brains, representing other universes, could also exist in this bulk, potentially colliding with each other and giving rise to new Big Bangs. This scenario suggests that universes are not isolated but can interact, albeit subtly, through gravitational forces or other higher dimensional phenomena. The calm cosmos, in its extra dimensions, might be part of a larger cosmic architecture. Then there's the mathematical multiverse, proposed by physicist Max Tegmark. This radical idea suggests that all mathematically consistent structures exist as actual physical realities. If a universe can be described by a set of mathematical equations, then it exists. This implies an infinite number of universes, each corresponding to a different mathematical structure, encompassing every conceivable reality. Our universe would simply be one of these mathematical structures brought into existence by its inherent consistency. The calm cosmos, in its mathematical elegance, might be a manifestation of pure abstract thought. The implications of the multiverse hypothesis for our understanding of reality are profound. If there are infinite universes, then every possible event, no matter how improbable, would eventually occur in some universe. This challenges our notions of uniqueness, destiny, and even the significance of our own existence. It suggests that our perceived reality is just one of countless possibilities, and that the boundaries of what is real are far more expansive than we can imagine. The calm cosmos, in its infinite variations, expands our understanding of what is possible. Furthermore, the multiverse hypothesis offers potential solutions to some of the fine-tuning problems in our universe. If there are an infinite number of universes with varying physical constants, then it's not surprising that at least one of them would have the precise conditions necessary for the emergence of life. This removes the need for a designer or a miraculous coincidence, suggesting that our existence is simply a statistical inevitability within a vast cosmic landscape. The calm cosmos, in its statistical probabilities, explains the apparent fine-tuning of our universe. However, the multiverse hypothesis remains highly speculative and faces significant challenges. The primary difficulty lies in the lack of direct observational evidence. How can we detect or interact with other universes if they are causally disconnected from our own? While some theoretical predictions might offer indirect evidence, proving the existence of a multiverse remains a formidable task. The calm cosmos, in its unobservable realms, presents us with questions that may transcend our ability to answer. Despite these challenges, the multiverse hypothesis serves as a powerful conceptual tool, pushing the boundaries of our imagination and encouraging us to question our most fundamental assumptions about reality. It forces us to consider the possibility that the universe is far more extraordinary and mysterious than we can currently comprehend. The calm cosmos, in its speculative possibilities, invites us to contemplate the ultimate nature of our reality. Let's now delve into the fascinating concept of collective consciousness and how it might influence our shared perception of reality. This idea, often explored in psychology, sociology, and spiritual traditions, suggests that there is a shared pool of beliefs, ideas, and moral attitudes that operates as a unifying force within a society or even across humanity. The calm cosmos, in its interconnectedness, might be a manifestation of a larger collective mind. Emil Durkheim, a pioneering sociologist, introduced the concept of collective consciousness, conscience collective, to describe the shared beliefs and moral attitudes which operate as a unifying force within society. For Durkheim, this collective consciousness is distinct from individual consciousness and exerts a coercive power over individuals, shaping their thoughts, behaviours, and perceptions of reality. It is through this shared framework that societies maintain cohesion and transmit cultural values across generations. The calm cosmos, in its social fabric, is woven with threads of shared meaning and interpretation. Carl Jung, the renowned psychiatrist, expanded on this idea with his concept of the collective unconscious. Jung proposed that beyond our personal unconscious there is a deeper, universal layer of the unconscious mind shared by all humanity. This collective unconscious contains archetypes, universal, archaic patterns and images that derive from the collective experiences of the human race. These archetypes, such as the hero, the mother, or the shadow, influence our dreams, myths, and symbols, shaping our perceptions and behaviours in ways we may not consciously realise. The calm cosmos, in its archetypal patterns, reveals the deep-seated influences on our shared reality. In a more contemporary context, the rise of global communication and social media has given new relevance to the idea of a collective consciousness. Information, ideas, and emotions can spread globally in an instant, creating rapid shifts in public opinion, collective moods, and shared perceptions of events. This interconnectedness suggests that our individual realities are increasingly influenced by a global collective, blurring the lines between personal and shared experience. The calm cosmos, in its digital networks, fosters new forms of collective awareness. Consider the phenomenon of mass hysteria or collective delusions, where a group of people experiences similar physical or psychological symptoms without any apparent external cause. These events, while rare, demonstrate the powerful influence of collective belief and suggestion on individual perception and physical reality. The calm cosmos, in its social dynamics, reveals the powerful influence of collective belief on individual perception. The concept of collective consciousness also has implications for our understanding of creativity and innovation. Many breakthroughs in science and art seem to emerge simultaneously in different parts of the world, suggesting that ideas might be in the air, accessible to multiple minds at once. This could be interpreted as evidence of a shared pool of knowledge or inspiration that transcends individual consciousness. The calm cosmos, in its creative flow, might be tapping into a universal wellspring of ideas. Furthermore, the idea of a collective consciousness resonates with various spiritual and mystical traditions that emphasize the interconnectedness of all beings and the unity of consciousness. These traditions often speak of a universal mind or a cosmic consciousness, of which individual minds are merely a part. If this is true, then our perceived reality is not just a product of our individual brains, but also a manifestation of a larger shared awareness. The calm cosmos, in its boundless unity, suggests a consciousness that transcends individual minds. However, the concept of collective consciousness, particularly in its more metaphysical forms, remains largely unproven by empirical science. While social and psychological phenomena clearly demonstrate the influence of group dynamics on individual perception, the existence of a distinct non-physical collective consciousness is a matter of philosophical and spiritual debate. The calm cosmos, in its philosophical depths, presents us with questions that may transcend our ability to answer. Despite these challenges, the idea of collective consciousness serves as a powerful reminder of our interconnectedness and the profound influence of shared beliefs and experiences on our individual realities. It encourages us to consider how our thoughts and actions contribute to the larger tapestry of human consciousness, and how, in turn, that collective consciousness shapes the world we perceive. The calm cosmos, in its intricate web of connections, invites us to recognize our role in co-creating our shared reality. Let's now delve into the fascinating concept of simulated reality in greater detail, moving beyond its initial premise to consider its profound implications for our understanding of consciousness, free will, and the very purpose of existence. If our reality is indeed a sophisticated computer simulation, then the nature of our being and our place in the cosmos take on an entirely new dimension. The calm cosmos, in its intricate design, might be a grand cosmic program running on an unimaginable supercomputer. One of the most intriguing implications of the simulation hypothesis is the question of consciousness. If we are simulated beings, is our consciousness also simulated? And if so, does that diminish its reality or significance? Some argue that if a simulated consciousness is indistinguishable from a biological one, then it is equally real. The subjective experience of being conscious, the qualia of seeing red or feeling pain, would be just as vivid and authentic within a simulation as in a base reality. This suggests that the nature of consciousness might be independent of its substrate, whether it's biological neurons or digital code. The calm cosmos, in its digital manifestations, offers immersive experiences that challenge our traditional notions of presence. Another critical question is that of free will. If our actions and choices are determined by the code of a simulation, do we truly have free will, or are we merely following a predetermined script? This is a long-standing philosophical debate, but the simulation hypothesis adds a new layer of complexity. If our universe is a simulation, then the programmers could potentially manipulate our experiences, alter the laws of physics, or even reset the simulation. This raises concerns about the extent of our autonomy and the true nature of our agency. The calm cosmos, in its simulated possibilities, challenges the very notion of free will. Furthermore, the simulation hypothesis opens up profound questions about the purpose of our existence. If we are part of a simulation, what is its purpose? Are we part of an experiment, a historical recreation, a game, or a training program for the base reality inhabitants? This shifts the focus from an intrinsic purpose within our universe to an extrinsic purpose determined by the simulators. It could lead to a re-evaluation of our values, our goals, and our understanding of meaning. The calm cosmos, in its grand cosmic program, might have an ultimate purpose beyond our current comprehension. The concept of meta-simulation also arises from this hypothesis. If we can simulate realities, then the beings in the base reality might also be simulated, leading to an infinite regress of simulations within simulations. This raises the question of whether there is an ultimate fundamental reality, or if reality is an endless fractal of simulated layers. The calm cosmos, in its infinite regress, presents us with questions that may transcend our ability to answer. The simulation hypothesis also has implications for our understanding of scientific discovery. If our universe is a simulation, then the laws of physics we discover might simply be the algorithms or rules programmed into the simulation. Anomalies or unexplained phenomena could be bugs or glitches in the code. This perspective could provide a new framework for scientific inquiry, encouraging us to look for patterns and inconsistencies that might reveal the underlying computational nature of our reality. The calm cosmos, in its subtle anomalies, might be revealing the underlying code of its existence. However, it's important to reiterate that the simulation hypothesis remains a speculative idea. There is no definitive scientific evidence to prove or disprove it. Yet, its power lies in its ability to provoke thought, to challenge our assumptions, and to encourage us to look at our reality from a different perspective. It forces us to consider the possibility that the universe is far more extraordinary and mysterious than we can currently comprehend. The calm cosmos, in its speculative possibilities, invites us to contemplate the ultimate nature of our reality. Let's now delve into the fascinating intersection of consciousness, reality, and the concept of flow states. Flow, a term coined by psychologist Mihaly Csikszentmihalyi, describes a mental state in which a person performing an activity is fully immersed in a feeling of energized focus, full involvement, and enjoyment in the process of the activity. In essence, flow is characterized by complete absorption in what one does, and a resulting transformation in one's sense of time. The calm cosmos, in its moments of profound engagement, reveals a heightened and altered state of reality. During a flow state, individuals often report a distorted sense of time, where hours can feel like minutes, or vice versa. This subjective time dilation or compression highlights how our internal experience of time can deviate significantly from objective clock time. This is not merely a psychological trick, but a profound alteration in our perception of reality, where the boundaries between self and activity dissolve, and the external world fades into the background. The calm cosmos, in its temporal elasticity, is shaped by our internal states of focus. Another characteristic of flow is a sense of effortless action and a feeling of being in control. Despite the challenge of the task, the individual feels a sense of mastery and competence, with actions flowing seamlessly from one to the next. This feeling of control contributes to a heightened sense of agency and a belief in one's ability to influence outcomes, further shaping their perceived reality. The calm cosmos, in its moments of mastery, empowers us to shape our own experience. Flow states are often achieved when there is a clear balance between the perceived challenges of a task and one's perceived skills. If the challenge is too low, boredom sets in. If the challenge is too high, anxiety arises. But when the challenge is just right, and one's skills are adequately matched, the conditions for flow are ripe. This suggests that our engagement with reality and our subjective experience of it is optimized when we are operating at the edge of our capabilities. The calm cosmos, in its optimal challenges, invites us to grow and expand our abilities. The experience of flow is intrinsically rewarding. The activity itself becomes the reward, rather than any external outcome. This intrinsic motivation is a powerful driver of human behavior and learning. When we are in flow, we are not driven by external incentives, but by the sheer joy and satisfaction of the activity itself. This suggests that the most fulfilling experiences of reality are those where we are deeply engaged and absorbed in the present moment. The calm cosmos, in its intrinsic rewards, offers profound satisfaction through deep engagement. Flow states have been observed across a wide range of activities, from sports and artistic creation to scientific research and everyday tasks. A surgeon performing a complex operation, a musician improvising a jazz solo, a writer engrossed in their craft, or a gardener tending to their plants can all experience flow. This universality suggests that the capacity for flow is an inherent human potential, a pathway to a more engaged and fulfilling experience of reality. The calm cosmos, in its diverse activities, offers countless opportunities for profound engagement. In conclusion, the concept of flow states provides a powerful lens through which to understand the subjective and transformative nature of our perceived reality. It highlights how deep engagement, optimal challenge, and a distorted sense of time can lead to heightened experiences of consciousness and a profound sense of well-being. The calm cosmos, in its moments of profound engagement, reveals a heightened and altered state of reality, inviting us to seek out and cultivate these experiences in our daily lives. It is a testament to the human capacity for absorption, a reminder that the most vivid and meaningful aspects of our reality are often found when we are fully present and immersed in the unfolding moment. In conclusion, our journey through the multifaceted concept of the illusion of reality reveals a universe far more intricate and subjective than our everyday perceptions suggest. From the inherent limitations and constructive nature of our senses, to the pervasive influence of cognitive biases, social constructs, and the mind-bending implications of quantum physics and the simulation hypothesis, it becomes clear that what we perceive as real is a complex tapestry woven from countless threads of interpretation, belief, and interaction. This understanding is not meant to diminish the richness or validity of our experience, but rather to deepen our appreciation for the extraordinary processes that create it. By recognizing that our reality is, in part, an illusion, we gain a powerful tool for critical thinking, empathy, and self-awareness. It encourages us to question assumptions, to seek out diverse perspectives, and to remain open to the possibility that there are always deeper layers of truth waiting to be uncovered. The calm cosmos, in its boundless mysteries, constantly invites us to look beyond the surface and explore the profound depths of existence. Ultimately, the illusion of reality is a testament to the incredible complexity and creativity of the human mind and the dynamic interplay between consciousness and the universe. It reminds us that our experience is not a passive reception of objective facts, but an active, ongoing co-creation. As we continue to unravel the secrets of perception, consciousness, and the fundamental nature of reality, we move closer to a more comprehensive understanding of ourselves and our place within the calm cosmos, a universe that is both profoundly real and wonderfully illusory. Let's now explore the fascinating realm of dreams and altered states of consciousness, and how they further blur the lines between what is real and what is imagined. These states offer profound insights into the brain's capacity to generate vivid, immersive realities from within, independent of external sensory input. The calm cosmos, in its nocturnal mysteries and expanded perceptions, reveals the fluid nature of our reality. Dreams are perhaps the most common and accessible altered state of consciousness. Every night as we sleep, our brains construct elaborate worlds, populated with characters, events, and emotions that feel incredibly real while we're experiencing them. We can fly, meet deceased loved ones, or find ourselves in impossible situations, all within the confines of our minds. Upon waking, we often recognize the dream as distinct from waking reality. But during the dream itself, the experience is often indistinguishable from our waking life. This demonstrates the brain's remarkable ability to create a compelling, self-contained reality. The calm cosmos, in its dreamscapes, reveals the brain's power as a reality generator. Lucid dreaming, where the dreamer becomes aware that they are dreaming and can even exert some control over the dream narrative, takes this phenomenon a step further. In a lucid dream, the dreamer is consciously aware of the illusory nature of their surroundings, yet the sensory experience remains vivid and immersive. This highlights the brain's capacity to maintain a sense of reality, even when the conscious mind knows it's a fabrication. The calm cosmos, in its lucid moments, offers a unique window into the constructed nature of our reality. Beyond dreams, various altered states of consciousness, induced by meditation, hypnosis, psychoactive substances, or extreme physiological conditions, can profoundly alter our perception of reality. During deep meditation, individuals may experience a dissolution of the self, a sense of unity with the universe, or a perception of timelessness. These experiences, while subjective, can feel more real and profound than ordinary waking consciousness, leading individuals to question the primacy of their everyday reality. The calm cosmos, in its meditative depths, reveals expanded states of awareness. Hallucinations, whether caused by neurological conditions, mental illness, or psychoactive drugs, are another powerful example of the brain's ability to generate reality. These perceptions, which are not based on external stimuli, can be incredibly vivid and convincing, leading individuals to believe they are experiencing something objectively real. This underscores the fact that our brains are not merely passive receivers of information, but active constructors of our perceived world. The calm cosmos, in its neural symphony, can create realities that are both internal and external. Near-death experiences, NDEs, are another intriguing phenomenon that challenges our conventional understanding of reality. Individuals who have had NDEs often report experiences such as out-of-body sensations, encounters with deceased loved ones, a review of their life, and a profound sense of peace and unity. While the scientific community debates the neurological and psychological explanations for NDEs, the subjective experience for those who undergo them is often transformative, leading to a fundamental shift in their worldview and their perception of reality. The calm cosmos, in its liminal spaces, offers glimpses into alternative dimensions of existence. These altered states of consciousness, whether naturally occurring or induced, serve as powerful reminders that our everyday waking reality is just one possible mode of perception. They demonstrate the brain's immense capacity to generate diverse realities, each with its own unique characteristics and subjective truths. By exploring these states, we gain a deeper appreciation for the fluid and constructed nature of our perceived world, and the profound ways in which our consciousness shapes our experience. The calm cosmos, in its boundless mysteries, whispers of realities far more complex and subjective than we often assume. In conclusion, the exploration of dreams and altered states of consciousness adds another compelling layer to the concept of the illusion of reality. They highlight the brain's extraordinary ability to create immersive and convincing realities from within, challenging the notion of a single, fixed, objective world. This understanding encourages us to embrace the fluidity of perception, to question our assumptions, and to recognize the profound role of consciousness in shaping our experience of the calm cosmos. It is a testament to the mind's boundless capacity for creation, a reminder that the most extraordinary realities may lie not just beyond the stars, but within the depths of our own being. Let's now consider the profound implications of the concept of free will for our understanding of reality. The debate over whether our choices are truly our own, or if they are predetermined by prior causes, has significant ramifications for how we perceive our agency, responsibility, and the very nature of existence. The calm cosmos, in its intricate dance of cause and effect, presents us with a profound philosophical dilemma. Determinism is the philosophical position that all events, including human decisions and actions, are ultimately determined by causes external to the will. This means that every event is the inevitable consequence of preceding events and conditions, governed by the laws of physics. If determinism is true, then our sense of making free choices is an illusion, and our actions are merely the unfolding of a predetermined causal chain. The calm cosmos, in its deterministic laws, suggests a universe where every event is preordained. Neuroscience has contributed to this debate by revealing the neural correlates of decision-making. Studies have shown that brain activity associated with a decision can be detected milliseconds before a person becomes consciously aware of making that decision. This has led some to argue that our conscious will is merely an after-the-fact rationalization of processes that have already been initiated unconsciously by the brain. If our brains are making decisions before we are consciously aware of them, then where does free will fit in? The calm cosmos, in its neural mechanisms, challenges the intuitive notion of conscious control. However, the implications of these findings are still hotly debated. Some argue that unconscious brain activity is not necessarily evidence against free will, but rather a reflection of the brain's efficient processing. They suggest that free will might operate at a different level, perhaps in our ability to reflect on our desires, to deliberate, and to choose among different courses of action over time. The calm cosmos, in its complex neural networks, allows for intricate processes that may or may not include free will. Compatibilism is a philosophical position that attempts to reconcile free will with determinism. Compatibilists argue that free will and determinism are not mutually exclusive. They define free will not as the ability to choose independently of all prior causes, but as the ability to act according to one's own desires and intentions, without external coercion. In this view, even if our desires are determined, as long as we are acting on those desires, we are exercising free will. The calm cosmos, in its philosophical nuances, seeks to bridge seemingly opposing concepts. Incompatibilism, on the other hand, argues that free will and determinism are fundamentally incompatible. If determinism is true, then free will is an illusion. This position often leads to either hard determinism, no free will, determinism is true, or libertarianism, free will exists, so determinism is false. The calm cosmos, in its fundamental laws, might lean towards one of these extreme positions. The debate over free will has profound implications for our understanding of moral responsibility, justice, and the very meaning of human existence. If we do not have free will, then how can we be held morally responsible for our actions? If our choices are predetermined, then concepts like praise, blame, reward, and punishment seem to lose their foundation. The calm cosmos, in its ethical considerations, forces us to re-evaluate our systems of morality and justice. Furthermore, the question of free will impacts our perception of ourselves and our place in the universe. If we are merely puppets of causality, then our sense of agency and purpose might be diminished. However, if free will is real, then we are active participants in shaping our reality, with the power to make genuine choices and influence the course of events. The calm cosmos, in its profound depths, holds the ultimate, secrets of existence, waiting to be unveiled by the curious minds of humanity. While there is no definitive scientific or philosophical consensus on the existence of free will, the ongoing debate serves as a powerful reminder of the profound mysteries that lie at the heart of our existence. It encourages us to reflect on the nature of our choices, the influences that shape us, and the extent of our autonomy in a universe governed by physical laws. The calm cosmos, in its intricate dance of cause and effect, invites us to ponder the true nature of our agency and the illusion of control. It is a testament to the human capacity for self-reflection, a reminder that the most profound questions often lead to a deeper understanding of ourselves and our place within the grand tapestry of reality. In conclusion, our exploration of the illusion of reality has taken us on a profound journey through the intricate workings of our senses, the biases of our minds, the constructs of our societies, and the mind-bending revelations of physics and philosophy. We have seen how our perceived reality is not a fixed, objective truth, but a dynamic and deeply personal construction, constantly shaped by a myriad of internal and external factors. This understanding is not meant to diminish the beauty or significance of our lives, but rather to enrich it. By recognizing the constructed nature of our reality, we gain a powerful lens through which to view the world with greater curiosity, empathy, and critical awareness. It encourages us to question assumptions, to challenge our own biases, and to embrace the inherent mystery that lies at the heart of existence. The calm cosmos, in its boundless intricacies, invites us to look beyond the surface and explore the profound depths of what it means to perceive, to exist, and to be conscious. Ultimately, the illusion of reality is a testament to the extraordinary capacity of the human mind to create meaning and coherence in a universe that is both wonderfully complex and inherently ambiguous. It reminds us that our experience is not a passive reception of objective facts, but an active, ongoing co-creation between our inner world and the outer cosmos. As we continue to unravel the secrets of perception, consciousness, and the fundamental nature of reality, we move closer to a more comprehensive understanding of ourselves and our place within the calm cosmos, a universe that is both profoundly real and wonderfully illusory. The calm cosmos, in its profound depths, holds the ultimate secrets of existence, waiting to be unveiled by the curious minds of humanity. It is a testament to the power of human inquiry, a reminder that the more we learn about the universe, the more we realize how much more there is to discover and how deeply interconnected we are with the fundamental fabric of reality. The calm cosmos, in its subtle whispers and grand pronouncements, constantly communicates with us through these myriad channels of perception. It is a symphony of sensations, a dance of data, and a profound invitation to explore the depths of our own being and the vastness of the universe. This continuous interplay between our internal sensory world and the external cosmic reality is what truly defines our experience, making every moment a unique and intricate tapestry of perception. The journey of understanding these hidden senses is an ongoing one, promising even more revelations about the extraordinary ways in which we are connected to the calm cosmos. The calm cosmos, in its profound depths, holds the ultimate secrets of existence, waiting to be unveiled by the curious minds of humanity. It is a testament to the power of human inquiry, a reminder that the more we learn about the universe, the more we realize how much more there is to discover, and how deeply interconnected we are with the fundamental fabric of reality. The calm cosmos, in its subtle whispers and grand pronouncements, constantly communicates with us through these myriad channels of perception. It is a symphony of sensations, a dance of data, and a profound invitation to explore the depths of our own being and the vastness of the universe. This continuous interplay between our internal sensory world and the external cosmic reality is what truly defines our experience, making every moment a unique and intricate tapestry of perception. The journey of understanding these hidden senses is an ongoing one, promising even more revelations about the extraordinary ways in which we are connected to the calm cosmos. The calm cosmos, in its profound depths, holds the ultimate secrets of existence, waiting to be unveiled by the curious minds of humanity. It is a testament to the power of human inquiry, a reminder that the more we learn about the universe, the more we realize how much more there is to discover and how deeply interconnected we are with the fundamental fabric of reality. The calm cosmos, in its profound depths, holds the ultimate secrets of existence, waiting to be unveiled by the curious minds of humanity. It is a testament to the power of human inquiry, a reminder that the more we learn about the universe, the more we realize how much more there is to discover and how deeply interconnected we are with the fundamental fabric of reality.